So now let's solve the second question on chapter 9. So the question asks if you walk through the still air at the rate of, and this is the velocity, at the rate of 1 meter per second, would you expect the flow immediately surrounding you to be dominated by viscous effects, inertia effects, or some combination? So now let's first calculate the Reynolds number, right? So whenever we want to know what is the viscous effect or the inertia effect, because the Reynolds number is the inertia effect over the viscous effect, this is why we need to calculate that. So let's assume that this is the person that we have, right? And it said that just approximate the body of the person, right? It said that assume that the body of person is like a cylindrical with the diameter of 50 centimeter diameter, right? So, oops, sorry. Okay, now this is what we have, and let's say that the velocity is going toward the person, and let's say that the velocity is u, right? Also, we need to know the, and it's air, right? So for the Reynolds number, which is UD nu, we need to know the nu of the air, which is 1.46 times 10 to the minus 5 meter squared over second, right? And then from here, and we know that the velocity is 1 meter per second, right? And the diameter is, if I just convert this diameter to meter, so we're gonna get 0.5 meter, right? And if we calculate that one, the Reynolds number going to be 34,274, right? And now we know that this is a moderate Reynolds number, right? So then yes, the boundary layer will develop around the person, and overall the flow respects I just said that it respects the Reynolds number, and it's consistent with the laminar flow, because we know that the critical Reynolds number, right, is approximately two times to 10 to the power of 5, and then so the flow immediately around the person is going to be viscous, and elsewhere it is going to be inertia dominated, right? So we also show it on that on the lecture. And if I want to show it, so if this is the person, this one, so here we have the viscous, and here we have the, oh, not like that, but here, let's show it like this. We have the boundary layer, and then everywhere else we have inviscid flow. Like for example here, outside of the body, so we have inviscid flow, right? And yeah, that's it for this question.